We are going to go over the concepts that are addressed in 11.2. And the whole entire point of 11.2 is we are taking what we were exploring in 11.1 and having to really use our brains to kind of Sherlock Holmes and figure out, what do these numbers and these sequences have in common? How can I move along a line? How can I write an expression? And we're going to be given the key to unlock the actual formulas to be able to write those expressions for the terms of a sequence. Okay, so then it feels like, why didn't you give me the formula in the first place? Right? So now that we understand how to find a sequence, let's logically work through what we are looking at. We know that a sequence is a list of numbers, and that to get from one number to the next, we have to jump there by either a common difference or a common ratio. So important values to know is that in these new equations, we're going to see a new variable called d. This is the common difference. We know that difference means subtraction, correct? And so if we are looking at it, it can also mean addition. Because if we are going from one to the next, from left to right, and adding, that is the same as going from right to left and subtracting and finding that difference. So when we are looking at addition and subtraction, which we learned were our arithmetic sequences, we are going to have this term of d, this common difference. Now, to go from one term to the next, if it deals with multiplication, we are going to have a term called r, and that is going to be a common ratio, which we addressed is for our geometric sequences, and those will be addressed in 11.3. We will go into depth for our common ratios. So currently, we are just going to deal with our common difference. That means we are only dealing with addition and subtraction. And it is telling us that to go from our first term to our second term, third term, fourth term, because these are our term locations. Quick reminder that we are going to have to either add or subtract the same thing all the way down the line. Now, logically, what can we figure out? If I start at 1, say my number is 1, and I am going to add 2 each time. So I'm going to go to 3, then I'm going to go to 5 and 7, and on down the line. Would it be valid to say that to find any number, all I did was take where I started and add however many jumps I made? So to get to 7, I made 3 jumps. I went 2, 4, 6. So to get to 7, I have 1 plus 6. Well, that works out. And what we find out is that's really what is happening. To find any term along our sequence, we can start at any other term, really, and just add however many jumps that we made. So then the important thing to know is, how many jumps are we actually making? Let's see what we have in common. If I go from 1 to 5, I make 1, 2, 3, 4 jumps. If I go from 1 to 3, I make 2 jumps. If I were to go from 1, that's what we have here, 1 to 7, I would make 6 jumps. So I hope what you're noticing is that we always have 1 less jumps than the actual number that we have. It's kind of like going back, if you do woodworking, we've also discussed this I would say probably middle school math when you're cutting a piece of paper. If you wanted to cut a piece of paper into 2 pieces, you make 1 cut. If you want to cut a piece of paper into 3 pieces, you make 2 cuts. Because what you are really doing is you're taking out the space in between and you're leaving your overall spaces. So that's what we're doing with our jumps. Our jumps, the number of times that we jump, will always be equal to our end number, which we refer to as n, minus 1. So if we have 6 terms, 6 minus 1, we will have 5 jumps. If we have 100 terms, we're going to have 99 jumps. And this is important to know that it's the number of times that you are adding this value. So then let's think about that. If I have 3 2's here, I can rewrite that as 3 times 2. This is the number of times I have this value, correct? So if I am jumping by 5, I have a value of 5. And how many times do I have it? Say I'm jumping 6 times. That means I would have 30 to add to my first number. So this logical reason plays into our formula that states that to find any term, all we have to do is take the very beginning and add whatever we are jumping, the number of times we are jumping, and they write it this way, n minus 1 times d. Okay, so let's think about what this is really saying. Any term, to find any term location, right? So a sub n, remember we've learned that this a sub n is telling us the value at this location. So when n equals 4, the value would be 7 here. It's just like our f of x, right? That I'm going to take the value of my first location, a sub 4, my value of my first location in this case, is 1. And I'm going to add to it the number of jumps that I am making, however many jumps, times the amount I'm jumping by, that we jump by. So in this case, we could say that a sub 4 is equal to 1. That's our very first one. So this is the beginning. I should have written that as beginning. Our beginning term plus I would jump 3 times, and I am jumping 2, adding 2 every time. So this would tell me that 1 plus 6 equals 7, and we got the same answer. Okay. So this formula is one that is very valuable to know that we can find any term in a sequence by starting at the beginning and simply jumping a certain number of times by a certain amount. Okay, so now that we have this formula that describes how to find terms, we can find our term if we know our starting value and our common difference, what we are actually jumping by and what term we want. We could find our starting value if we know where we ended up, because then we know how many times we have jumped. We could find our common difference if we know where we start and where we ended. So now that we have an equation, we get to go all the way back and use our toolbox of information where we can plug in numbers and solve for a variable. We might have 2 variables. We know that with 1 variable, we need 1 equation and we can solve it. If we have 2 variables, we need 2 equations to be able to solve them. If we had 3 variables, we would need 3 equations to be able to solve. So we're getting to go back and use all of our toolbox information that we have previously learned to be able to find different parts of these sequences. Okay, so the beginning of your homework simply asks you to state whether a sequence is an arithmetic sequence. So in that order, remember, you might see a geometric sequence, but they are specifically asking you whether or not it's arithmetic. Arithmetic always uses addition and subtraction. If there is no common value that is either added or subtracted between numbers, it is not an arithmetic sequence for that. For 21 through 29, it's saying write the rule for the nth term of the sequence. Now, what they have given is they have given a list of numbers already, and then they are asking for what is the rule and what is the value of the 25th term in the sequence. They write it as A25. That means if you were to write out all of your numbers, you are finding the 25th value. They're saying, what is the value at that location? Okay. And so for this, we can either use our guess and check method that we learned in 11.1, or we can use our formula that we have. So let's look at 21 and see what they give us. They give us 1, 3, 5, 7, and 9. Okay. First and foremost, do we know the first value? Yes, we see that our first term is the number 1. So I'm going to erase my first term and I'm going to put the value 1 right there. Okay. They are asking us to write a generic rule first. So we are going to leave our n values as generic values. We're not going to plug an actual number into them. But we're going to look and say, do we know what our common difference is? Let's see, what are we jumping by? From term to term, it looks like we are adding 2 each time. So I'm going to erase my D, and I'm going to plug in the value 2 into that one. Now we must simplify. So we're going to say A sub n is equal to 1 plus, we use distribution with our 2, and we're going to write 2n minus 2. Now we have like terms that we can combine. So we have A sub n is equal to negative 1 plus 2n. This could also be written as 2n minus 1. Now we have a generic expression that tells us to find any term, and they are specifically asking us for A25. So we can say A25 is equal to 2 times 25 minus 1, and that should give us the value of 49, right? What if we went ahead and plugged that back in here at the beginning? And they tell us A sub 25. I know I start at 1. I know I am jumping 25 minus 1, so I would be jumping 24 times, 2 times, and I'm jumping to a value of 2 each time. So I'd have 1 plus 24 times 2 gives me 1 plus 48 gives me 49. We got the same answer both ways, which you should always end up with the same answer. So for those parts of your homework, you can use the guess and check method, but now that we have been given the formula that helps us find any value, let's use that to find our expression for our sequences. Okay, let's look at number 25. We have a list of numbers, and it says 1, 4, -2, -5, and -8. Okay, I want to go all the way down to 25. What am I jumping by? Let's see if we have a common difference. Well, each time it looks like I'm subtracting 3, minus 3 for each one. So minus 3 is our common difference. So I'm now going to plug in negative 3 for our common difference. I also know that I start at the value 4. So I'm going to erase my first value and I'm going to plug in 4 right there. So now our generic sequence is 4 times, let's distribute this out, negative 3n plus 3. I could say that a sub n, to find any term, I'm going to take 7 and subtract 3n from it. So as they now ask us to find the 25th term, we're going to simply plug in 25, 3 times 25 here, and we're going to get our answer to be negative 68 for that. Okay. So as we use our generic formula, we can find those generic expressions for any of the terms. Okay. On 30 through 38, what they have done is instead of giving you the list of numbers and asking you to find D, they give you D in the first place. They might say D is already equal to 4, and then they're giving a specific term. So for 30, they say A14 is equal to 46. Now, how do we use our generic formula with what we have to find what we don't know? Remember, the whole part of math is we are taking what we don't know and we're using it. We're taking what we know and we're using it to find what we don't know. Well, we know that we have a formula here that it's valid for finding an arithmetic sequence. We know we have a D, so we're going to plug that in. So we've got 4 over here. I'm going to write it out. Okay. And we have a certain value. So we really have a sub 14 is equal to whatever our first term is. They didn't give us that. Plus 14, because this is our n value, 14 minus 1. That makes sense. We're jumping 13 times, and each time we jump, we're jumping by a value of 4. Now, what do they also tell us? They also tell us that a sub 14 is equal to 46. And so by substitution, I can erase my a sub 14, and I can replace it with the value of 46. Well, now I have an entire equation that has one variable, and if I have one variable, I can solve it with one equation, so that works out. So we're going to have 46 is equal to a sub 1 plus 13 times 4. Okay, so in this case, we have 13 times 4 is going to give us, what, 52 in that case. So now I have a sub 1, 46 equals a sub 1 plus 52. Solve for a sub 1. He wants to go to the movies by himself. So when we change sides, we change signs. It's also the same as subtracting. And we're going to end up with the difference. Let's do 52 minus 46 gives us 8 in that case. All right. So we can say that we are starting at the value, our a sub 1, we are starting at the value of negative 8. All right, is that right? Nope, 4. 6, sorry. Totally wrong on that one. The value of 6, negative 6. There we go. Okay, so now what do we do? To find our generic, we get to go all the way back up. So for generic, we need D and we need a sub 1. Let's plug this, erase this out. Okay, and we're going to say to find any value, I start at negative 6. I'm going to jump a certain number of times, and every time I jump, it's going to be 4. Let's simplify. -6 plus 4n minus 4. I have like terms that I can combine. A sub n equals -10 plus 4n. So we were able to find our generic value even though we did not have our first term. We only had the 14th term and our jumping value. So as you move through those equations, they're going to give you different values. You're going to have a D value each time for some. And then for some, you might just have 2 different values. So let's look at what that might look like. So for example, 33 tells us that A sub 5 is 17 and A sub 15 equals 77. So we have this sequence, and the 5th term is 17, and somewhere down the line on the 15th term, I wrote 17. We have 77. So we're trying to figure out where did we start and what are we jumping by. So we don't know where we started, and we also don't know what we're jumping by. But we do know some certain terms. We know that to get to number 5, we had to jump 4 times. To get to the 15th one, we had to jump 14 times. So let's use our equation and see if we can use what we do know to find out these values over here that we don't know. So initially for A sub 5, we have A sub 5 is equal to this A sub 1, which we don't know, plus we know that we would be jumping 4 times, and we don't know how many times we're jumping by. However, we do know that this value of A sub 5, they have given it to us, and they have said that this value is 17. So by substitution, we're going to replace that. So I know that 17 is equal to A sub 1, my starting point, plus 4D, right? The problem lies that I have 2 variables. And for 2 variables, I must have 2 equations to be able to solve it. Well, they gave us another one. Let's look at that. We have A sub 15 is equal to wherever I started, plus I know I would have to jump 14 times something. And by substitution, I'm going to replace A sub 15 with the value of 77. So now I have 77 equals wherever I started and 14 jumps of this value D. Well, what we have given ourselves is we have given ourselves 2 equations with the same 2 variables, and we can solve 2 equations with the same variables. We can do it by substitution, or we can do it by elimination. I'm going to put the small one on the bottom. And I'm going to subtract my entire equation. We could also multiply through by a -1 and add. It's the same thing. 77 minus 17 gives me 0. 7 minus 1 gives me 6. A sub 1 minus A sub 1 is going to give me 0. 14D minus 4D is going to give me 10D. So now I simply have 60 equals 10D, and I can say that D is equal to 6. So now I no longer have a question mark. I'm going to plug in 6 over here. Now, because of substitution, we can go back and we can plug in our D value into any of these. So let's plug in, not to that one. Sorry, guys. Let's plug in our D value down here. And instead of having D, we're going to plug in 6 so that we know that 17 equals wherever I started plus 24. So A sub 1 plus 24 equals 17. I'm going to change sides, change signs, or subtract off. So I have 17 minus 24 gives me -7. So I started at -7. So now we have a starting value and we have a D value, which means that we can go all the way back up and we can plug them into our generic expression. So my starting value was -7. I've got this n minus 1. My D value is 6. We're going to simplify and say -7 plus 6n minus 6, and we get our generic value equals -13 plus 6n. Okay, what you might begin to notice is that once we get down to our simplified expression, we no longer have our a sub 1 term. What we actually have is the term right before it. So we've gone from a sub 1 to a sub 0. We've backed up one term. So if we were jumping by 6, we would now be subtracting 6. And -7 minus 6 gives us -13. So this is actually our a sub 0 location. And then it allows us to just say, jump the number of times that you need to jump to get there. Because to go from 0 to 15, you need to go 15 times. To go from 0 to 8, you need to go 8 times. And so it has backed us up to 0. What that actually does, if we were to graph it, it has actually backed us up to the y-axis where we now have a y-intercept. And we can notice that this, say I rewrote it as a sub n equals 6n minus 13, right? This looks a lot like y equals mx plus b, where our value, our starting value is our y-intercept. And in this case, if I say a sub 0, so when x equals 0, I'm at -13 down here, we find that it is in fact our y-intercept on the graph. We also find that the amount we are jumping by is our slope, because every time I go over one, I'm going up 6, and I go a next one, I'm going up 6. And so our generic expression becomes the equation of the line to graph this entire sequence. Okay. Now, to take everything that we now know about our sequences and to be able to find any sequence, we know that we can use our sequence formula here. So how do we actually transition that to series? And I'm going to stop and do a separate little video for that one.